comma, 10 million, comma, the mean, comma, the standard deviation. Because we estimate them, we have to ask ourselves, we have to adjust the endpoint, which is looking at this thing here, do we include 94, which is in this case, you see that we include the 94. And to include the 94, everybody see that I need to move it to the left. And to move it to the left, I need to subtract 0.5, which is my endpoint is 93.5. So I know my endpoint, then now all I need to do is plug into this item, which is the normal CDF, the lower limit, which is 93.5, the upper limit, which is 10 million. The mean, we did it, which is 99.6. And the standard deviation, we did it, which is 4.1148511152, right? So again, that is your objective, is to looking for this 4 item when you're using the normal CDF. And in this case, if you plug it in, this thing will give you 0.9309. Okay. So again, question, everybody see the difference between this problem where they ask you to find or approximate, they don't ask you to find. Okay.
Yes. Mm-hmm.
So if they ask you to find and you use the other one, you don't have to adjust anything. Okay. So similarly to A, B, they ask you to approximate the probability that fewer than 90. So what does it mean? Fewer than 90, meaning X is less than 90, right? So we're looking for X less than 90, meaning we look for the area to the left of 90, which is, again, we go here and again, we sketch our small mountain, right? And then 90 is here, less than 90, meaning something on the left of 90, which is now looking at this thing here, do we include the 90? We don't, right? We don't include the 90, so how can we exclude this thing here? We have to go to the left, right? We have to make it smaller, and if I go to the left, I subtract 0.5, which is, again, this thing will give me my endpoint as 89.5, which is, again, now I know that on the left side, my smaller endpoint will be negative 10 million, and then my bigger endpoint will be 89.5, and the mean and standard deviation is the same, which is, this is what I have. And lastly, hopefully you guys see that this is redundant from yesterday. Lastly, approximate the probability that a number of such Google is between 100 and 110. But inclusive, meaning, again, inclusive meaning we include, is basically is equal to 100 or smaller or bigger, right? And smaller than 110 or equal to 110. That's include 110 and 100. So if we know that this is what we have, which is, again, the probability of X between 100 and 110 inclusive, meaning we include the endpoint. So we know between is easy, which is between is this, which is 100 and 110. And I'm looking for this area in between the two value, and I include them. How can I include the 100? Well, if I go to the right, that means I exclude them. To include them, I have to, from 100, I have to go to the left. And again, to go to the left, you subtract 0.5. And again, at 110, I include the 110. And to include the 110, I have to add 0.5. Which is, now I know that my endpoint is 99.5 on the left side, and my right side is 110.5, which is, again, once I know the endpoint, I can see that this is all I need to do is put in my small endpoint, my upper endpoint, my mean, and my standard deviation, and I should have the answer. So question here in terms of how to spy the difference, right? How do you, using the word that they give you, to determine, do we use a regular normal CDF or the normal CDF with the adjusted sample standard deviation, or when do we adjust the endpoint in terms of the 3 problems we have, or when to use the inverse norm?
Wait, I have a question really quickly. When you use the PDF format, that's usually when you're looking for an exact number, correct?
We never use normal PDF. We only use binomial PDF, so we never, ever use the normal PDF.
Okay, right, okay.
So don't worry about the normal PDF. Just delete that. You cannot delete it. Just don't worry about it.
Okay.
All right. So another question here in terms of A, B, and C. You don't have a question? Let's take a look at this item here, which is, again, hopefully you guys see that this problem is the same as the previous problem. The only thing different is, instead of write it out, spell it out, they give you in a notation form, right? So looking at this thing here, how do we know that we need to adjust the endpoint? Well, they spell it right here. They tell you to use the normal approximation. So again, that's the only time that you need to adjust your endpoint. And if you look at this thing here, this is also the time that we need to find the mean and the standard deviation because they don't give it to us. So most of the time when you find the mean and the standard deviation, that is when you have to adjust your endpoint too. Okay, so again, they tell you here, let's X have a binomial distribution, right? So we have a binomial distribution of n equal to 240, and the probability of the success is 0.38. Using the normal approximate to find the probability of X is greater than 83. So before we can do this thing here, you have to find your mean, which is reminder to find your mean, you have to take the n times the p, which is, this is your mean, 91.2. And you have to find your standard deviation, which is a square root of n times p times 1 minus p, which is, again, I use this whole decimal, which is 7.519574456, right? So once we have that, now you go in and you sketch your graph, right? You sketch your bell-shaped curve. So mine 83 is somewhere here. It doesn't have to be exact, right? 91 is the mean, so 83 have to be a little bit on the left, which is, again, somewhere here, right? So looking at this thing here, I'm looking for X bigger than 83, which is, do you agree that this is an item? I'm looking for the item on the right. And because I don't include the 83, I need to exclude the 83, which is I need to move it to the right so that I can exclude the 83, which is if I move it to the right, I have to add 0.5. So given this thing here, everybody see that this is my endpoint here. I have the 83.5, and my upper limit is some humongous number, and the mean is 91.2, and the standard deviation 7.519574456. So question in terms of this problem, and again, hopefully you guys see the connection of this problem to the previous problem, which is just the same, okay? I changed it. The other one is example 3, and this one example 4. I switched in the slides. But again, looking at this thing here, hopefully you guys see that it's very redundant. The only thing different here is instead of say more than 83, they just put this notation. And again, this thing here is pretty much the same as the previous C, which is between 75 and 95 inclusive, right? Because we have an equal sign, we include the endpoint. And if we include the endpoint, which is, again, this is what we have, which is 75, 95. And again, we're looking for the area in between. And if we're looking for the area in between, which is now, before we can type this thing in, we have to use the approximation, which is we have to adjust the endpoint. Do we include the 75? And in this case, we do. How do we do that? Well, to include the 75, we have to go to the left. And again, if I go to the left, I subtract 5. And to include the 95, I have to go to the right. And to go to the right, I have to add 0.5. Which is, again, this is what you guys should have, which is your lower limit, your upper limit, 74.5, 95.5, and the rest is the same. And again, this thing should give you 0.7031. And again, probably C, you all saw this, which is, again, we know that 96, and we're looking for the item less than 96, right? Anything on the left is less than 96. And now, if it's less than 96 and I don't want to include a 96, I have to move to the left. And to move to the left, I need to subtract 0.5, which is, again, this is what we need to do, which is, again, left side, our interval, which is, again, some negative, humongous negative number, and then 95.5. And lastly, this thing is what we have is we're looking for the item greater than or equal to 86, and not 86, 89. And again, 89, which is we include the 89. And in order to include the 89, I need to go to the left. And if I go to the left, I need to subtract 0.5. And if I subtract 0.5, my endpoint will be 88.9. Okay. So question with this thing here, question with when we have to find the mean, the standard deviation, and adjust the endpoint. Or any question with this particular problem here? All right. If you don't have a question, that is basically it for chapter 6, ladies and gentlemen. And again, we spent a lot of time on it to get the understanding of the sketching and the item. Let's go back to chapter 5, right? Chapter 5, we went over chapter 5 way back when, before the midterm, right? And then midterm happened. So looking at this thing here, let's say that we have this, which is, remember 5.1 is we have the probability distribution, right? So in order to be a probability distribution, reminder that you have two items, right? You have the data, which is your data can be any number, right? In this case, again, my data is the number of pet, right? A number of pet a family owned in a neighborhood. And again, the second thing that we have is we have to have a probability. That's why we call probability distribution, because we have some data and we have the probability distribute throughout the data, right? The other thing, or one thing is, in order to be considered a probability distribution, make sure that all of your probability is between 0 and 1, which is in this case, none of my probability is bigger than 1 and none of my probability is negative, so I have that checked, right? The second thing to verify if this is a probability distribution is all of your probability. If you add all of this number, it must be equal to 1. So if it's not equal to 1, it's not a probability distribution, because the maximum probability is 1 and you cannot distribute it throughout and it's more than 1. You only have 1 to distribute it out, right? So given this thing here, this is the distribution, right? This is probability distribution that we have. So now looking at this thing here, they pretty much ask you to find this item, which is find the probability at a random selected family have 1 or 2 pets, right? Which is, in this case, is basically tell you that if we have this distribution, can you extract out the information that fit this criteria? Which is, do you agree that this right here, this is the family, the probability of family have 1 pet, and this is the probability of the family have 2 pets, right? So again, to know that this thing here, the probability of 1 or 2, which is a mutually exclusive, because again, either the family have 1 or a family have 2, which is now, if it's mutually exclusive, all we need to do is take the 2 items and we add them, which is we go in here and we just take the probability that fit the description and then add them together, right? And again, they will challenge you and they say more than 2 pet, which is more than 2 pet. Hopefully you guys say, oh, more than 2 pet, that's mean the 3 or the 4 pet, right? We do not include the 2 pet because 2 is not more than 2, right? So again, how many family, what is the probability of a family have more than 2 pet, which is, again, we have the 3 and the 4, which is greater than 2 pet, which is, again, 0.075 plus 0.025. And again, if you add them together, will be 0.1, which is 10%, right? Which is, as you can see, 10.1 plus 0.1 is 0.2, 0.2 plus 0.5, I mean 0.3 is 0.5, and 0.5 plus 0.5 is equal to 1 whole number. And that's why this thing here is a probability distribution, okay? And again, lastly, looking at this thing here, they just changed the word, right? What does it mean? Find a probability of no more than 3 pet. So what does it mean, no more than 3 pet, right? We heard up here more than 2, meaning again, the 3 pet, the 4 pet, no more than 3. Do you agree that the 0 is not more than 3, right? the 1 is not more than 3, the 2 is not more than 3, and also the 3 is not more than 3, right? No more than 3 is basically tell you that find the probability of 3 or less, right? Because 4 is more than 3, so again, it's not in the no more situation, right? No more than 3, meaning basically it's the same concept. It's just that, you know, they can say find the probability of 3 or less pet, right? But they changed the wording, and hopefully you guys see that no more than 3 is basically find the probability of x. In terms of this, x is the number of pet, which is x less than or equal to 3, right? So if you add all this together, will give me 0.975. Okay, so again, the hardest part of this class is you know, they give you all this word and all this English language, and sometimes you have to convert to a math equivalent, right? And that's where a lot of students doesn't like it, in the sense that of the wording. But again, that's one of the things is, you know, you have to dissect, analyze your information, right? And question would see why no more than 3, meaning again is 3 and less, right? No more, we cannot exceed 3, right? So that's why we have to use the 0, the 1, the 2, and also the 3, because the 3 is not more than 3. Okay. So looking at this thing here, if you remember, what about the at least 1? Well, at least 1 meaning again is 1 or more. If you remember, I told you that if you go to casino, you have to be at least 21 to go in, meaning 21 and above, right? So again, at least 1 meaning you take the 1, you add it with the 2, you add it with the 3, and you add it with the 4, which is 50%. Or if you remember, you don't have to do it because they give it here. If you remember, at least 1 is the same as 1 minus none, which is 1 minus 0.5 is the other 0.5. Okay. So again, question with this thing here, it's been a while since we go back and visit this probability distribution. Question with this probability distribution here. And now, if you don't have question, this is where the last thing we have in 5.1 is how do we find the mean and the standard deviation given the probability distribution. So again, we did that big, massive table, and I told you eventually you don't need to do that massive table. We don't have to find the x square times the probability and then subtract the mean square, right? We don't have to do those by hand. Your calculator can help you, which is hopefully you got to remember that this is what you guys need to do is you need to enter in your data, which is the number pet for us in L1, enter in your probability in L2, and then we go and we choose the 1 var stat L1 comma L2. Once you have this thing here, which is again, let me share you guys. So again, if you remember, this is what we do is, let me clear this thing here, which is again, in order to type in, you have to hit stat. For those of you who forgot how to enter this thing in, you have to hit stat and then edit, which is again, if you hit stat, edit, and then you press enter, this is your L1, which is, I already did this. Your L1 is 0, 1, 2, 3, and 4. Your L2 is 0.5, 0.3, 0.1, 0.075, 0.025. So again, this is your L1. Make sure you have your L1 and make sure you have L2. Don't delete your L1 and L2. If you happen to delete it, you have to get it back. Okay. Anybody delete your L1 and L2? All right. So once you type in L1 and L2, you have to hit stat again. And then you scroll over to calculate, which is if you scroll over, you have the 1 var stat, which is we choose the 1 var stat. And then you have to hit second number 1 for L1, comma, second number 2 for L2, which is again, 1 var stat L1, comma, L2. If you have the 84, then your list is L1, your frequency is your L2. You have to type it in L1 and L2 to tell your calculator to use that. And again, once you press enter, this is the mean, which is the X bar, which is 0.825, and your standard deviation is 1.046. which is again, that is your answer here, which is the mean is 0.825 and your standard deviation is 1.046. So question here, and again, if you have trouble of how to enter in, we went over this in 5.1. Look over the 5.1 slide. I post the PowerPoint slide for 5.1 on Canvas and the video. So look over those items if you have question. But anyway, question with this example 5. And if you don't have question, let's take a look at the last problem. This is the last problem I have for you guys, which is this is the one that you guys mentioned is the binomial PDF and binomial CDF, right? So again, what is the difference between this problem versus 6.4, right? Remember 6.4 is you deal with a normal distribution that approximate the binomial. The difference is this is in 5.2, the sample that we are given or the sample that we have is very small. Well, not very small, but it's small, right? The criteria, remember in 6.4, the criteria is in order for you to qualify to use it, the n times p have to be bigger than 10. The n times the 1 minus p have to be bigger than 10. This thing here, if you take the 0.2 times the 12, that thing will not be bigger than 10. So again, we cannot use the normal approximation, okay? And if you remember in 6.2, in order for us to use the adjustment, your n have to be bigger than 30, okay? And that's why both of our problem earlier is 40 and 110 or something like that. But anyway, this is hopefully you can spot the difference, right? Spot the obvious. Right. So look at this thing here. They tell you that at a large clothing store, 20% of all purchased items are returned. A random sample of 12 purchases is selected. Find the probability of exactly 3 of the purchased items were returned. So if you look at this thing here, what does it mean exactly? Well, exactly meaning we have to calculate at that exact location. And to calculate that exact location, we have to use the binomial PDF. The binomial PDF, which is again, looking at this thing here, how do we do this problem? Which is we need to identify my n, which is 12, my p, which is 0.2, and again, my x, which is exactly 3, so the x is equal to 3. Which is again my binomial PDF, which is I need to have an n, which is the total item. I need to have the p, which is the probability of success, and I need the x, which is those are the 3 things I need, which is now I plug in 12, 0.2, 3, which is the probability of exactly 3 out of the 12 people returning the product is 23.6% or 0.2362. Okay, so again, looking at this thing here, is in 6.2, I mean not 6.2, 5.2, and again, the difference between A versus B is B, they ask you for a range of number, right? They ask you for a range of number, a group of number, a cumulative item. And because they ask you for a cumulative item, we need to use the binomial CDF. But before we can do that binomial CDF, again, this is what you need to ask yourself is, are we looking for the item to the left or to the right of this item here, right? So find the probability that more than 2 of the purchase. So what does it mean more than 2? Do you agree that more than 2 meaning 3, the 4, the 5, the 6, the 7, the 8, the 9, the 10, and the 11 and 12, right? So more than 2, which is the number of items on the right of 2. And make sure that, again, because your calculator, or because my calculator, you might have a better calculator, because my calculator can only calculate the cumulative item on the left side. For me, my binomial CDF can only calculate to the left side of the value. So I tell my calculator to calculate up to 2, right? Calculate the 1, calculate the 2, calculate the 3. Add them all together, because I'm looking for more than 2, so again, basically, if I can calculate up to the 2, what do I need to do? Well, because I'm looking for the item on the right, and the calculator give me the answer on the left, I have to take 1 minus the left side, which is I have to subtract this thing here, which is, again, the answer will be 0.4417. Okay, so again, my calculator can only calculate the item accumulation of the item from the left hand side. So that's why, because I'm looking for it on the right, I need to tell my calculator calculate it, and then I subtract from 1, because the maximum probability is equal to 1. So if I know the item on the left, I subtract from 1, I have the item on the right. And again, if you have problem with how to determine the x, the endpoint, I make that flow chart in 5.2, and I post it on Canvas. You can look at that flow chart and to see how to determine your endpoint. Okay, and lastly for C, fewer than 2. Again, fewer than 2 meaning, again, do you agree that we do not include 2? We only include the 0 and the 1, because the 0 and the 1 is the item fewer than 2. So again, you can do 2 things, which is you can do the binomial CDF of a 1, right? The 12, 0.2 and 1. Or if you want, you can do the binomial PDF of the 0, binomial PDF of the 1, and add them together. The answer should be the same. Okay, because we only have 2 items, we can do the individual item and then add them up. If we have like 10 items, we don't want to do the binomial PDF of 0, of 1, of 2, up to 10, and then add them up, which is time consuming. That's why we use the CDF. Okay, but again, that's the difference between binomial CDF versus binomial PDF. CDF is cumulative, and again, PDF is 1 exact point. Okay, so we never ever use normal PDF. Okay, like I mentioned earlier, we don't use normal PDF, so don't ever type normal PDF. You only use binomial PDF versus binomial CDF. The other one is you use normal CDF and the inverse norm. Those are the only 4 features. Okay, and lastly, how do we find the mean of this item? Remember, to find the mean, which is we need to take the n times the p, which is we did this in terms of the approximation, normal approximation, right? Which is, again, if you take this, you have 2.4, and to find the standard deviation is a square root of n times p times 1 minus p, which is, if you plug it in, you should have square root of 192, which is 1.3856. Question with this thing here, this is in 5.2, which is we kind of step away right before midterm and then attack chapter 6. So again, hopefully this thing here bring back some item that we cover in 5.2. The other thing that I did not give you in this review is they might give you the z-score and they ask you to find the area. Reminder, if they give you the z-score, the mean, the standard normal is, the mean is 0 and the standard deviation is equal to 1. Okay, so again, if they ask you to find the z-score, you just plug into the z-score formula. If they ask you to find an error given the z-score, if they give you the z-score, meaning it's a standardized, and if it's a standardized, the mean is equal to 0 and the standard deviation is equal to 1. Okay, all of the problem I give you doesn't have a standardized item. That's why we plug in the mean like 192 and the standard deviation is like 120 or something like that, because it's not standardized. If it's standardized, the mean is 0, standard deviation is 1. Okay. Well, question with example 6 here,